Okay, so we just took a look at a GCF. Now we're going to look at something like this. X squared plus 2x minus 3. And we're going to call the number, so off to the right I've got ax squared plus bx plus c. And in English I've got a is the number to the left of the x squared. B is the number in front of the x term. C is the number all by itself. Notice I didn't forget the sign. So if ever I don't see a number in front of a number like x squared, I'm going to put a 1 in front. So, as you can see in the notes, I listed them off to the right, but I'm going to do a little trick. I'm going to put them right above. A equals 1. B equals positive 2. C equals negative 3 from the pattern off to the right. A is the number to the left of the x squared. B is the number to the left of the x. C is the number all by itself. Don't forget the sign. So we really want to look out for when A is 1, or when we get something like 2x squared minus 3x plus 4, where A is equal to 2. Where A is not 1. And that's going to be a big decision on how we make decisions going forward, whether or not A is 1 or A is not 1. I hope you start to recognize these things because it's going to make your life in the future a lot easier. So A is 2, B is equal to negative 3, and C is equal to positive 4. Make sure that you label A, B, and C. Off to the right, I've got an example with letters. And further off to the right, I've got 2x squared plus 4, where B is 0 because there's no middle term. Or x squared plus 4x, where C is 0, where there's no last term. So, usually when something's not there, it has a value of 0. Okay, so now let's take a look at an example. Just going to shrink this up a tad. So let's go for x squared plus 5x plus 6. Now, we're going to do it the proper way first, and then we're going to learn the correct method. So first of all, I want to recognize, is A 1 or is A not 1? Well, I'm going to put a 1 in front. A is 1. And if A is 1, I can follow the following steps. Blank times blank equals the C value. The last value, C is 6. And blank plus blank equals the middle number, B, and B is 5. So we can cross out C and say 6 and cross out B and say 5. So what are two numbers that multiply to get 6 and add to get 5? Well, first of all, I'm going to write all the numbers that multiply to get 6. 1 and 6, 2 and 3. Then I'm going to look at the combinations of those numbers to see which one makes 5, 2 and 3. So I'm going to put them in the addition statement. Then, 2 and 3 in the addition statement. Then I'm going to put those numbers directly above. I'm going to confirm that the multiplication statement works. 2 times 3 is 6. And I'm going to take the numbers that I just figured out, 2 and 3, and I'm going to separate the middle number into plus 2x plus 3x. And I ask you questions like, how do you feel about that? Well, we just changed a 5x to a 2x plus 3x. We haven't changed the value at all. That's allowed. And we can carry everything else down. So we have 1x squared plus 6. Now, lots of the times I'll rewrite stuff in the notes and then do the step, but in the videos I'm just going to do the step. So brackets around the first two things, brackets around the second two things, vertical bar. This does not mean multiplication. Remove a greatest common factor. The greatest common factor between the first set, they both have an x. I'm going to skip a line. So I'm going to take out an x, and I'm left with x plus 2. Now, the second set of brackets, we have a positive 3 and a positive 6. So we can take out a positive 3. Positive 3, we're left with x plus 2. 3 times x is 3x, 3 times 2 is 6. Now, they both have an x plus 2. So we can take out an x plus 2. Where have we learned that? On the last page. And we're left with an x plus 3. Circle your answer. We've now successfully factored this to be that. Figuring out what two things multiply together to make that something. Now let's learn a quick method. So let's take the same question, x squared plus 5x plus 6. Now the numbers that we figured out were 2 and 3. And if a is 1, I'm going to write it near the 1. If a is 1, box around it. If a is 1, then we can simply set up our brackets and think from last year. What times what is x squared? So we put an x and x, because x times x is x squared. Then we just put the numbers that we figured out above, 2 and 3, in the red box. 2 and 3, both positive. Circle our answer. So those are going to be quick methods. The method on the left is called decomposition. The method on the right is just a quick method of decomposition. So be careful with that. Always remember to what? Check your answer. So we're going to take our question, we're going to rewrite it. Then we're going to distribute. 1, 2, 3, 4. If you forget how to do this, go back to last year and remember how to first, outsides, insides, lasts, FOIL. X times x is x squared. X times 3 is positive 3. Positive 2 times, positive 3x. Positive 2 times x is positive 2x. And 2 times 3 is positive 6. Circle your answer. Excuse me. Combine like terms. X squared. Positive 3x plus 2x is plus 5x. And we have a plus 6. Circle your answer. It's exactly where we started. So check your answer. Always checking your answer. So down below, x squared plus 6x plus 8. A is 1. Two numbers that multiply to get 8 and add to get 6 are 4 and 2. So x plus 4, 4 and 2, 4 and 2, x plus 4, x plus 2. FOIL it out, check your answer. Last example, x squared minus 3x minus 10. Blank times blank equals negative 10. Excuse me, recognizing that a was 1. Blank times blank equals negative 10. Blank plus blank equals negative 3. Those numbers are 5 and 2, 5 and 2. Look at the negative line to decide which one needs to be negative, the negative 5. Put that negative above. Confirm that the multiplication statement, negative 5 times 2 equals negative 10. And we can set up our brackets. And x times x is x squared. And we can put the numbers we just figured out off to the right inside our brackets, negative 5 and positive 2. Check your answer. Put an x into the question. Put an x into the answer. Make sure they're the same. Or FOIL this thing out and make sure that the answer is correct, as we did above. Excuse me, as we did here for the question above, and then two little examples down below. Don't forget about the signs. Don't forget to check your answer. Okay, so now we took a look at when A is not 1. We're now going to take a little bit farther, delve into when we looked at when A is 1. We're now going to look at when A is not 1. And we're going to see the similarities and differences based on those.